right. So we're going to take a look at this. Are you ready for more? Because I think this is a really interesting problem. A function that uses the price in dollars per download uses the price x to determine the number of downloads in thousands is 18 minus x thousand. Is an example of a demand function, and its graph is known. Demand in the context of like supply and demand. So demand, supply is how much of a resource is available for people to purchase. Demand is how many people would choose to purchase that resource. Um, and its graph is known. Economists are interested in factors that can affect the demand function and therefore the price suppliers wish to set. This is actually a really it's a really useful thing to think about. I don't know if people know, but like Netflix, for example, just recently decided to increase the price per month for their service. And that's definitely going to affect how many people are choosing to purchase that service. And so, if the company made the correct predictions, they will increase their revenue. But if their predictions are not correct, then they're going to decrease their revenue, which would be a problem if you're a company trying to make money. So anyway, so I'm going to let you think about some things that could increase the number of downloads predicted for the same given prices. And if you're stuck, like think about Netflix, like as the price for Netflix increases, like what are some things that might influence the number of download or the number of people who subscribe to it? Just an idea. Okay, so the number two, if demand shifted so that we predicted 20 minus X thousand downloads at a price of X dollars per download, what do you think will happen to the price that gives the maximum revenue? Check what actually happens. So it's going to change, right? So essentially what we're doing is we are taking, instead of the 18 value for the revenue function and the demand function, or the download function, and instead of that 18, we're doing this function. R of P equals P times 20 minus P. So like the question is, what does this do if I change that value? Okay. I'm going to go ahead and let you make your own prediction. So go ahead and pause if you haven't like made a prediction yet, and make your own prediction. And then we're going to look at Desmos to see what actually happens. Okay. So here I want to go to Desmos. Okay, cool. So we're in Desmos now. So this red graph here is the original function. X is 18 minus X. We're going to do another one. And I don't want, I'm going to do X times, oops, I did one numbers, 20 minus X. Okay, so here, and it looks like I need my y-axis to go a little higher. Let's go up to like 125. I think that'll work. Yeah, that's good. And I think let's make that go a little farther. 25. Yeah, we can really see it. Okay. So we can see here that and let's choose, I'm going to choose blue. That this here, the maximum revenue here, looks to be, we're going to get 10,000 downloads and 100,000 dollars in revenue. Whereas for the original one, it looked like 9,000 downloads and like $81,000 thereabouts. I don't know. I'd have to go back and look at the table. But yeah, so increasing the demand function, like if you can create more demand, then you can sell more downloads and make more money, I guess is what this is trying to show you. So, and I also just kind of wanted to, I wanted you to notice that, like that seems like a really hard question to answer, but if we can just type it into Desmos and use a graph to analyze it, it makes things a lot easier. So I encourage you, whenever you're unsure about something, go to Desmos, graph it, see what you think, because that visual is a really powerful tool, and Desmos is so easy to use once you learn how to use it that it's a really quick way for you to um, like analyze a function. So anyway, great. Have a great day.